Hello everyone, welcome to the Dome9 webinar, AWS Network and IAM Security Best Practices. My name is Thelen Blum. I'm the Senior Product Marketing Manager at Dome9, and I'm here with Patrick Pusher, Dome9's Technical Evangelist. In today's webinar, Patrick is going to answer the question of how leading-edge cloud-enabled organizations are leveraging the next generation security capabilities to provide the insight they need to make sound security decisions. He will review vendor-independent AWS network and IAM security best practices with practical examples that showcase how to keep up with the pace of change in your environment and protect it from prying eyes. And lastly, he will briefly introduce the Dome9 Arc platform as a means to achieve even greater network and IAM security visibility, control, and active enforcement. We will close with Q&A at the end of the session. A couple of housekeeping notes before we get started. This webinar is being recorded and will be made available afterwards. All attendees are in listen-only mode. If you would like to ask a question, please type in the question window of GoToWebinar, and Patrick will address as many questions as possible, time permitting. Without further ado, I will now pass the ball to Patrick. Let's get started.
Thank you so much, Thelen, and thanks everyone for joining us for the next about 45 minutes. Just one other small housekeeping item is that I've uploaded some of the solution and product briefs into the handout section of GoToWebinar. So there we have the compliance engine, the Dome9 DevOps solution, and the Dome9 IAM safety product briefs there. So although Dome9 will be probably a smaller piece of sort of what we talked about today, I think we're going to focus more on industry-driven best practices. We'll tie in how Dome9 sort of speaks to these challenges at the end, but just know that there's some additional sort of supplementary information there. Okay, so just to set the stage in terms of expectations of what we'll cover today, we're going to talk a little bit about the challenge, why we need reviews like this on an ongoing basis. We'll talk a little bit first about IAM-based security best practices. We'll then focus on network security best practices, which is really Dome9's traditional focus. I think the Dome9 product, as of a couple of years now, has a more broader perspective than simply network security, but it's where we started. And then we'll introduce Dome9 after that, again, probably for a maximum of about 10 minutes. And then if we have some time left, we'll do Q&A. If we don't get to Q&A, I will answer your questions directly via email. So if you're obviously if you're registered with a proper email address that you monitor, you will get a response. Quite often we do run out of time. You'll find that I really have a passion for this stuff and I like to talk, and unfortunately that means sometimes we butt up against the end of our time. So with that, let's get going. Really, I think the challenge is about this combination of capability provided from AWS and how we leverage that capability from our side, from the customer side. I think we're all relatively familiar by this point with the shared responsibility model popularized by AWS, but we don't talk often about why it's a challenge, and it's really twofold. I think organizational needs change over time as an organization gets more mature with all sorts of things, certainly including infrastructure as a service usage, and even just external things, mergers and acquisitions, everything, the life cycle of sort of data management within an organization is ever changing. And then you couple that with capabilities from our technology partners, AWS in the case of our topic today. I have a tab up in my browser. Once we get to the demo portion, if we have time, we'll look, and the amount of services introduced from AWS last year in 2016, is pages and pages and pages long. It's in the hundreds, and knowing exactly first that they exist, what each does, and then the capabilities of each service is a challenge for anybody. And so we have these two kind of forces ensuring that we always must know what the capabilities are and how to best leverage them. So looking at best practices, looking at how other organizations do it. Often AWS will publish best practices, but really what we're doing is aggregating our knowledge from working with many enterprise customers over the past 6 years and sharing that knowledge with you. So first, let's talk a little bit on the IAM side, then we'll get to the network security side. And we'll start with some basics. Some of these best practices have a slide each. These don't, and that's because most of these should be familiar. These aren't so to do with public infrastructure as a service. These are more sort of fundamental. So things like never using the account with the most built-in privilege, the root account, making sure that you are building distinct users for distinct purposes, making sure that you have a strong password policy. Definitely not new, but we'll talk about in the next slide why it's more important than ever, why it's more important than the data center days. Managing permissions with groups rather than directly, and this is really kind of a security at scale problem. As we start and as we have a handful of users, assigning them direct permissions is tempting because it's easy to get started, it's easy to understand once you start, but scaling that out to an enterprise full of users and along with identity or federated identity kind of use cases, this can get really, really complicated. So group-based administration, of course, over direct assignment of rights is definitely preferred, and AWS is no exception there. And then employing MFA across your account-wide, right? Not turning it on for each user, but making sure that it is a staple that's enforced continuously within your AWS usage. Again, no surprises there, but why are we calling them out again? In the case of public infrastructure, well. Why we do is that we've really transitioned away from this notion of perimeter security. And sometimes we talk about that in the context of just general network security, but I'd like to talk about it more in the context of service and authentication, service consumption and authentication, because what we used to do is we would have a filer, we would have a network core, we would have a hypervisor, and maybe we employed something like Radius, which would point to a single kind of account database, but even there, it was always fractioned. Not everything supported Radius. We would have independent kind of account databases per technology stack or vertical that we were interested in, and we protect that all with a perimeter. That's quite a bit different than what we do now. In lieu of that, when we are all in from an AWS perspective, we are going to one vendor for our file storage, our block storage, our DNS, our database as a service, our hypervisor, and the list goes on. Not from a lock-in perspective. There's lots of ways to get data in and out of AWS. That's not the concern. The concern is we now have one control plane to control all of this. And we have one account database and one control plane. And as good as that is in terms of automation potential and building scalable systems and efficiency, the one thing that's not great for is that those with malicious intent know that there is exactly one target instead of 4 or 5 or 6 or 10 disparate targets. They know there's one place to compromise, and effectively, if you can do that, you've got your keys to the kingdom. So that's why the basics are reinforced, and it's why we talk about some new concepts as well that are really inherent more towards the public cloud than our traditional data center environments. And the principle of least privilege isn't new. The principle of containing a blast radius isn't new. But again, within this context of one ring to rule them all, if you will, it becomes even more important. So really, we should be creating distinct users, never using that root account as we positioned last slide or 2 slides ago. But when we create those distinct users, we should be ensuring that they have the amount of privilege and only have the amount of privilege required for their job function. I think quite often, out of convenience, out of, we've built a template for a user, we just want to copy that, and we wind up giving our new user, the user in current question, too much privilege because of, out of convenience. And we have to fight that temptation for sure, and do this legitimately every single time, and make sure that we do follow that privilege of, or that principle of least privilege rather. When we do, we're effectively limiting what we call that blast radius. If there is an account compromise sort of event, what that compromising party can do is limited to the privilege you've built that user. If we employ the root user account, or if we employ, privilege that is far above what each user or what each role needs, then we open up this opportunity for a account credential kind of event, which if we're being responsible, we're thinking about, right? We're not thinking about it's impossible because we use MFA. We're thinking about there are still scenarios where this could be possible. Namely, what if I'm working at my workstation and I'm authenticated into AWS console with MFA as I should be, and I'm tapped on my shoulder and taken away from my desk, right? That's a vector. And we talk about insider threat all the time, yet we sometimes don't link these things together. And so if that account, which that user is logged in currently using, has that principle of least privilege, then we're much more able to contain any damage that could occur due to an event like that. Then we talked about group-based administration, but let's talk a little bit about roles. Roles are different. Rather than sharing credentials, sometimes we do this to simplify administration. If we have 5 web administrators in our environment, we may have less than 5 credentials, and there could be some sort of sharing going on. Again, if you've looked at the AWS IAM rights model, it is very, very thorough. It's not to say it's complicated, but it's thorough, and it can be overwhelming. And sometimes, again, we're tempted to share credentials because we share job roles. It kind of fits. Yet it takes away the responsibility that we have to make sure that we can identify any incoming changes to a particular user or a particular sort of use case or purpose. And so for users, it's important to maintain distinct credentials and then leverage IAM roles within AWS. You log in with your credentials and then you assume a common role, because now you're still properly authenticated. We know who you are, and we get around this problem of of having to clone or templatize or remember or otherwise copy rights from one user to another. We simply make one role, and everybody who needs that role is assigned access to it, and they assume it. Same thing for federated accounts. There is a special type of cross-account access that's role-based within AWS, and that can be leveraged to link in part or in whole 2 different AWS accounts that have a relationship to each other. And you might say, why would I ever do that? That's certainly a best practice. It's not outlined in our webinar today, but if you've got a production environment, and if you've got a staging environment, and maybe you've got more environments than that, it is a best practice to be able to segregate those with a hard line via account. Because again, if you've got accounts that are privileged enough and everyone has at least one that can that has perspective over your production, over your staging, and maybe even more context in your environment, you're at a disadvantage. If I have to do 2 or 3 or 4 sort of compromise events as somebody with malicious intent to get all of your infrastructure, that's infinitely more hard than a single one. And so when you do that, many organizations don't do that because of that complication. And now how do I reference between those accounts, and how do I make sure they're consistently administered and updated together? That becomes a challenge. So using sort of cross-account roles can make that easier, and can sort of let you follow that best practice with less complication. And then in the last few cases for third-party account integration, if you're using third-party tools, that cross-account access really gives the power to the end user. You can specify exactly via an AWS policy document what you want that third-party tool to have perspective into, and what both in kind of what it can read, but also what it can write back, what it can sort of change or alter in your environment if that's of interest as well. So that third-party cross-account role access gives you all the power to say, hey, if I ever fall out of love with that third-party vendor, I'll simply change or delete my my policy document, and they will have no access to my environment. It's a really, really scalable and secure model. So with that, hopefully that gives you kind of a feel for, some of the basic, a refresher on some of the basic IAM security principles, why they're important, and then maybe some new perspective on the sort of public infrastructure as a security side as well. With that, let's maybe transition over to the network security side, and we have a fair bit more ground to cover here, so we'll move a little bit quicker. The first thing to do that we recommend is to ensure that your VPC Flow Logs, which really are your firewall filter log as a service are turned on and enabled at a VPC or a subnet level. You can enable them at an individual network interfaces level too. And I think in, for certain troubleshooting perspectives or instances, that can be powerful too. But for organizationally wide, make sure they're turned on at a VPC level or at least a subnet level. And really what, they're going to be that perspective into all of the accepted and rejected network traffic flowing through your EC2 instances, security groups, load balancer, and a few more select AWS services. And again, they're not that different from a firewall filter log you have worked with before. and there's pros and cons. One is that we're used to the format. The con is that, it's not all that human readable. So many customers will take that information and make sure it makes its way to a SIM tool such that it can make some sense out of that data, because it's not all that human readable. It comes in a format which, all the data is there, but some context is very, very helpful. And so I'll show you how VPC Flow Logs is sort of handled within Dome 9, kind of where you have exposure to them and how they can help you detect behavior that isn't normal at the end when we get a chance to look at Dome 9. But regardless, make sure these are on, make sure you're utilizing them, and make sure you're doing more than dumping them to a storage bucket as well. On the topic of logging, make sure that you are utilizing CloudWatch, which is kind of an outside-in system monitoring capability within AWS, and CloudTrail, which is more of an API call monitoring capability. And you might say, I don't really leverage the API that much, but the AWS console is sort of a public implementation of the AWS API. Another way to say that is every button or every click or everything you input into that console is translated to AWS API underneath the covers anyways. So it turns out if we monitor the API, we monitor everything. And that's what CloudTrail does. CloudTrail will tell you when somebody clicked on something or some operation called an API and effected a change. You will find that information in CloudTrail. So we can log security group events, and past that, one of the really interesting things you can do from there is you can create event streams. And event streams then can be triggered from what CloudTrail finds and can be responded to by a lot of things, but one of the more exciting things are AWS sort of serverless Lambda functions. And I have an example kind of here on the screen. Let's think through this use case where an instance is created. If you're employing CloudTrail properly, an event's captured, and now a response to that event can be triggered via Lambda. That might take a look at that workload and do some consideration. Maybe we look at some tags, a naming standard, attributes, maybe what our network port exposure looks like. And that Lambda function can even do things, right? Yeah, it can tell you, it can send you an email, but it can actually even affect change because that function is of course within AWS and understands your environment. We can pass parameters in and out. There's lots of potential to affect change based on conditions found from CloudTrail and Lambda. It's all a little bit involved, but it's not as involved as spinning up an instance, passing API calls into something you build yourself, trying to build intelligence kind of from scratch. Lambda allows you to, completely get rid of that instance or workload, run functions straight from AWS, functions that are very AWS aware, and that's key as well. So make sure that you are leveraging both of those capabilities because, our goal is security situational awareness. And our further goal, depending on your scale, is making sure that awareness is maintained via automation, not leveraging people when our environment gets to a certain scale. And that's a challenge. We'll talk about that more later. So the next thing is, again, not super new, but leveraging a naming standard, both in how you name end resources, but also in how you name things like tags, will have repercussions in terms of your automation efforts later as well. So the main reason we do this is to make sure that you can't really decipher what content is in a service or a workload based on its name, right? A naming standard is important because we want to know from a glance, what a service or workload is intended for, to know how to govern it, either interactively or by some sort of automated means. And so we want to make sure that that we understand the naming standard, yet we want to make sure it doesn't give too much away. And there's some examples kind of in the text of the slide. -win, -lin for Linux, -x86 for an Intel 32-bit platform. Even names like jump host. They give those with less than perfect intent too much to go on, too much information, right? As a jump host, I know that people will be logging on to it. So there is some open port exposure. Maybe you're trying to hide it away. You're not using the standard ports of these services, but I know they're there because I know that it's a jump host. And I know that there's some outbound access allowed from that machine, likely into the sort of further depths of your network. All because you called something jump host. So just make sure that they're intelligent names that make sense to you internally, but don't give too much away in terms of what's contained within those services or workloads. The further consideration is, once you get to that stage of automation, you want your automation framework, routines, whatever you want to call it, you want that to be able to identify those resources properly, right? And if you have something tagged incorrectly or not towards or not with a standard or named, even worse than a tag, not with a standard that makes sense, then those automation routines won't be able to work in a predictable way, and that's the whole point of that exercise in the first place. So lots of reasons, some secure, some more efficiency, but make sure that that you're using a naming standard that makes sense and isn't too obvious. The next thing has to do with the relationship between security groups and service or workload. Maybe it's not apparent, but this is a sort of multiple relationship kind of capability where one workload or service can have more than one security group assigned to it. And when that happens, or even when you've got overlapping rules in a single security group, AWS is going to choose the most permissive rule. Some people think that wouldn't be the way it happens, but it is. So in this case, we have an SSH example. If I have an SSH in my inbound rule set, if I have an SSH allowance for one IP address, and then either in another group or somehow another rule, I have an allowance for everybody, everybody will have access. It's that most permissive rule that wins. And multiple security groups are often required to cover the range of port access policy needs, right? We see organizations, one security group's applied, to do with the application tier, one security group's applied to do with the OS of choice, right? Am I using RDP or SSH with different sort of obviously port parameters versus regarding Windows or Linux coverage, that sort of thing, and even maybe an additional security group applied for the flavor of administrative tools and the access they need that correspond to the business unit supporting the application. So not to mention the limitation of a single security group and how many rules you can have in it. I mean, there are hard limitations that make this impractical to have one security group per resource. So as you do it from the outset, really think about this and try to minimize overlap and try to make this as intelligent and sort of structured from the outset as you can. Because it does really get difficult to understand for any particular workload or service what that effective policy is. 2 security groups with a handful of rules is one thing. 5 security groups with 15 rules apiece makes this an entirely different exercise. And stay away from that complication if you can. If you can avoid it, make sure you have the tools in place to or process in place to ensure you understand. Okay. Continuing on from that, we often get questions around, what's standard and how do I do this? If one isn't enough, but 5 with tons of content is too many, what should my environment look like? And I think there's no answer to that, but if we have these 3 considerations in mind, maybe it'll help. One security group, cutting across multiple tiers. So if I use one security group for my databases, for my web servers, for my load balancing, it creates too much exposure in the resources that are isolated. We don't have one resource doing all that. We have separate disparate resources. So when a web server is covered by a security group that's got so much coverage, what if a web server has a small listening service on a port that's associated on your load balancer with something entirely different? And you've opened it up because it's needed, but now on your web server, there's a service running that listens that is entirely different, and you've, through no direct fault of your own, trying to make this simplified, you've opened that inadvertently. So that doesn't work. Don't do that. It's too much exposure, and if you have no sensitive data in there, I guess it's a practice you could employ, but I would stay away from it for sure. Use at least distinct security groups for distinct purposes or resources. Now, one security group for every resource is the other side of the coin, right? It's too cumbersome, and to manage operationally, especially at scale, that gets to be a challenge. So, okay, so we can't do it every resource. How should we do it? Let's make individual security groups for unique purposes, right? Unique app tiers, and that's where I think we achieve that balance between efficiency and security, where we can say, okay, we don't have to reinvent the wheel every time. We've got a new web server coming in, assign it the web server security group. I mean, of course, make sure that what you've built jives with kind of the rules in that web server security group. You can still have that case we talked about earlier, where you inadvertently have a new service that's different than the rest of your web servers, and you expose a port because you haven't, maybe it's used for a different purpose on a different web server. But going for tier-based classification in terms of your security group architecture makes the most sense, and I think you'll find scales the most when you start to grow. Quite often best practices will say, don't use really broad port access, any sort of rules against any service. And I don't know about you, but when I hear that, I kind of, I sigh, because it's not real. You have to use these. The key is use them in the proper place and use them strategically. For a service or a workload whose role is to take broad traffic, judge it, and send it deeper into your network, thinking something like an upfront web server, or even more appropriate, an upfront load balancer, that's its job. It needs a broad port policy to do that. So it's appropriate there. But as that sort of traffic judgment happens and gets filtered deeper into your network, it has to stop at that edge, and within the tiers of your app, your web tier and your database tier, for example, they have to be configured to only listen from the tier that's expected to send them data. And if you remember, there was a compromise, I think it was last month, it might have been about 45 days ago now, and it was with a children's toy that recorded voice messages from their parents, and they're able to sort of record messages back and forth. Given the sensitivity that it's children, quite private information, not private classified, in a formal way, but private information. And one of the things that was done very, very wrong in this compromise was that the tiers of the application were not constructed this way, and they were wide open, kind of configured to listen to absolutely anybody, and that is just it's completely uncalled for. Where you need that, but where you don't, you can't tolerate it, and you have to make sure that the app tiers are filtering traffic towards where it's expected from. And if traffic's coming in from a different source, it needs to be dropped, it needs to be recorded in your flow logs, and it needs to be understood why it's happening. If it's a misconfiguration, great, but if it's something else, potentially malicious, it has to be identifiable as well. So this is probably one of my favorites, and that is because we have a Dome9 capability that speaks directly to this, but I promise you, this is not my best practice. This is actually one from my mentor, for one that I had long before I joined Dome9. But it's the Swiss cheese firewall at the bottom is my moniker for sure. But it really boils down to understanding that you need a policy that says my service exposure is, just like we said on the account side, that principle of least privilege, that the principle of sort of least service coverage, if you will, is very, very important in a security group. However, there will be exceptions. There will be exceptions when we have to open up a port or a service for a period of time, hopefully not forever, that traditionally when we do this, we follow a change management process, we get people involved, and that invariably over time, maybe not the first or second or even 10th time this process is followed, but over time, we make mistakes. And if we can automate this in a way that takes us out of the process, us as people and individuals with schedules and lunch hours and phone calls that ring in the middle of trying to set up an access control list, you know, we can automate this and we can improve the accuracy of this to a large degree. We will come back to this. There's a feature in Dome 9 specifically built for this. In fact, it was our very first feature in the platform 6 years ago, and it's you know, it's purpose built for this use case. But you know, this is something you'll find in a lot of sort of best practice guidance, and it's something we want to call out for you today. This is our last best practice before we take a closer look at Dome 9, and maybe we'll look at a few slides kind of leading up to that to sort of paint the picture of what we're all about. But this one really has to do with the change management process that your organization has and your ability to match your technical process to it. You know, I think when you have light change management control, you are able to automate a lot. You are able to, you know, get out of this heavy-handed process whereby all this, you know, pre-paperwork has to be done. Of course, if you're following data security standards, much of that has to be done to satisfy that. But technically, in the environment, to stay secure, you know, may not have to be done when automated. Enterprise IT is a little bit different. Certainly can automate just as much, but can't do it in an ad hoc way like a startup or an SMB can. A startup or an SMB can be very comfortable building the Lambda functions we talked about earlier in the presentation, tying those to CloudWatch events and CloudTrail events, rather, CloudWatch logs. But doing that kind of for every service you use, for every use case, every condition, creates this, you know, this patchwork of solutionry, if you will. And for enterprise IT, that doesn't work. That doesn't scale. What they need rather than that is a framework, right? Where enterprise IT can represent what's important to them, and then that framework can be used over and over and over again to judge infrastructure, right? To measure it, to make sure it complies. I hate using the word compliance because it conjures up this, you know, a formalized kind of thing. So let's maybe talk about compliance and governance, the ability to ensure on a continual basis that, you know, all of your infrastructure, how you use it, how it's configured, is conforming to, you know, your desired end state. That's really the goal. So we have a bonus best practice that doesn't really have to do with network security or IAM security, but it has to do with what we're about to talk about, and that is Dome 9. If you're using Dome 9 or any really third-party tool to achieve what we've talked about in this webinar so far, just make sure that that tool is able to be used in a non-interactive way. Namely, make sure it can be automated, even if that's not where you are today and you're just getting your feet wet with AWS. You know, that slide we looked at with the collapse of the perimeter network, and you know, it was made to illustrate the fact that, yeah, we have one control point, and that control point is a little bit scary from an exposure perspective, but it's hugely empowering from an automation perspective. Being able to, you know, leverage tools or write automation using, you know, basic API calls to accomplish what, you know, you need to do based on conditions. Make sure that your third-party tools do that as well, so that they fit in your workflow. You do not want, you know, one thing we don't want to do, and I'm sure you've experienced this before if you've sort of been in IT for any length of time, when we bring in a new tool or process, we want to make sure that goes as smooth as possible, such that acceptance of that process is natural and straightforward. When we bring in, okay, we have a new tool, and plus we need to, you know, change entirely how we go about managing with this tool because it doesn't fit into our existing process, you know, the ability to sort of get the most out of that tool for everybody to really leverage it the most is somewhat you know, is somewhat compromised. So make sure that it has enough API coverage. Make sure the formats of data in and out of that tool are familiar to you. Maybe are the native formats that you represent your data in already. Just make sure it fits into your environment, and the API is a big piece of that. Okay. So with that, I would love to introduce you to Dome 9. We're going to do this in the next 10 minutes, including questions, so it'll be fast. The Dome 9 platform has grown a lot. I shared with you this, feature called Dynamic Access Leasing, which was our first feature 6 years ago. For not even for a dedicated cloud platform, right? Since then, really, we sat back and we said the future for the need of security, visibility, and control for us was in the public infrastructure as a service kind of area. Our pedigree, our founders come from network security vendors and perspectives, and they saw that the tool set we had in the data center it won't suffice for the tool set and the capabilities we need in the public cloud, and so we've built these capabilities specifically for the public infrastructure as a use case, public infrastructure as a service use case, and made sure that everything you can do interactively you can also do by API, and then made sure we had enough service coverage. In this slide we see AWS, we see Azure, we actually support Google Cloud Platform as well, in a somewhat limited fashion, but getting bigger and bigger every day. And then across the top, the ways to get data in and out of Dome 9 are varied as well, right? We have that very expansive API. We have the ability to send data to your favorite SIM tool of choice, and many of them create their custom Dome 9 connectors already based on sort of our success in the marketplace. We have lots of ways to make sure you're actively alerted and notified about changes in your security state. We have a beautiful console that I'll show you next in terms of being able to really amalgamate all this information, and all this information across not only multiple AWS accounts, but as we suggested in the bottom bubbles here, across multiple cloud providers, and represent them in, I know it's a really, really overused term, but in that single pane of glass interface, right? In a familiar interface with rules that sort of transcend one particular cloud provider. So we're going to look at that next. A couple things. So Dome 9 is a SaaS-delivered security orchestration product, purposely built, purposely for the public cloud. We integrate for the most part with API. We do have a Dome 9 agent that does some very, very particular things that we can't do with API. Things like doing file integrity monitoring at a host level. There is no API from AWS that will allow us to do that. There's nothing actually running from AWS in the workload that would do that in the first place. So we have an agent that does that, but everything we really talk about in this webinar and in most conversations with Dome 9 is powered by that deep API integration. So no agents, no appliances, no data even to load at all. And it scales, the security suite scales with your efforts, not against them, right? You're not using proprietary appliances to filter traffic or firewalls. You're leveraging AWS security groups, but you're benefiting by the leverage, the control, the visibility that Dome 9 provides you back. Within Dome 9, you will find that you can fix problems. This is not a read-only tool like a SIM tool is. I mean, SIMs are hugely powerful, don't get me wrong, but Dome 9 is able to provide you a lot of that same information, not as a SIM replacement, but also provide you the ability to affect change. And more than that, for Dome 9 to affect change on your behalf if certain conditions are or are not met. So lots of automated potential right within Dome 9, not trying to sort of glue it into your existing automation framework. There's lots of automation potential right alongside the Dome 9 offering as well. And then on the compliance and governance side, a capability for you to sort of write one policy and measure everything you do against it continuously. And that policy, is hugely descriptive across a number of AWS services, not just network security, not just IAM, and we'll take a look at that as well. But we better get to it quick. We don't have a lot of time left. So let's have a look then at Dome 9. So this is your Dome 9 dashboard, and the first thing we want to take a quick look at is the service that really corresponded back to one of our best practices, and that was to make sure that when exceptions happen, we deal with them pragmatically, and we deal with them in an automated fashion. And that's one of the things that Dynamic Access Leasing, a Dome 9 feature here, is very, very good at. What we do, instead of having very, very broad port access policies, kind of these any rules, which is another one of our best practice do-nots, we take a service, and it's really, any service is a great candidate for dynamic access leasing. In this case, it's an SSH service and it's a web service. And when they're under this feature, they are completely closed from a network access perspective, right? If I do a port scan on these services, I will get no result. Yet, as an employee that needs access to them, I can come to Dome9 and click this Get Access button. And Dome9 will figure out, what my current IP address is, what my level of privilege is, and allow me that level of access against this resource for that period of time. And remember we talked about taking the human element out of this. What happens at the end of that 1 hour is that Dome9 never forgets to come back, clean this up, remove my exception, and create an entry in the Dome9 audit trail that all this happened, right? So it's a way to keep your attack surface on really any service very low, yet provide means for anybody or anything. The dynamic access leasing is triggerable by API, as I promised. Everything that you see me do interactively is. So that's a capability again to let Dome9 handle the lifecycle of an exception, so that it never ever gets misaligned with your security policy. Next thing I want to talk about is Dome9 Clarity. Clarity is this Visio diagram kind of tool that first illustrates the relationships between VPCs within AWS, if any. I mean, we have some islands down here where there are no peering relationships between VPCs. But then as you dig into a particular network, it gives you a security group-centric view of what that VPC looks like from an outside-in port exposure kind of perspective. So, in the DMZ we have security groups that are, far too permissive. They have one or more any sort of rules in them. Again, if you need it, that's one thing in the case of a load balancer. But if you don't, and in the case of a default security group, there's lots of things going wrong here in our demo environment. But it too has a very permissive SSH rule. That's why we've painted it into this DMZ swim lane versus partially open versus internal zone, right? The DMZ partially open means we have some services that have some whitelisted exposure, but not nearly as permissive as the any rules we find in the DMZ. Back in the internal zone, we're more talking about security groups that only accept traffic from other security groups or private hosts in this network, right? So right away, we have the ability to understand this. And if we turn on VPC Flow Logs, here is where we will bring in that VPC Flow Log information that we talked about was so important at the outset of our webinar and paint it over Clarity. And if you're doing a regular security audit, these little red legends that appear tell you how much drop traffic based on the information, the intelligence from flow logs has happened in each security group. And for a regular security audit, it's a great way for you to say, okay, I expect a fair bit of drop traffic out here in the DMZ where that's sort of the filtering job, but why does my database server security group have so much drop traffic? It's got this full red bar. It means there's a ton too. That's either something going on like a misconfiguration, or maybe there's some lateral movement in my VPC, and maybe that's some not so above board kind of activity. But it gives you the starting off point. And then when I click a security group, I can actually work through that data. I can work through that firewall filtered data supplied by flow logs in a much more interactive kind of human readable format. I can dig into where an IP address kind of belongs from a geolocation perspective. I can filter. I can do all sorts of good things. But this is one of the prime places we bring in VPC Flow Log information inside of Dome9. Okay, lastly, let's talk quickly about compliance. This is probably where we should spend the most time. We have dedicated webinars for this. I urge you to visit dome9.com/webinars to sign up for one. It's revolutionary without going too far, kind of tooting our own horn. It really is. The feature ships with the ability to choose an off-the-shelf standard, like you see I have selected with PCI DSS here, or to craft your own. And I've just got a handful of rules that shows you the power in writing your own rules. Here's a rule that says, an instance should have been launched from one of 3 pre-approved AMIs, right? And show me when that's the case or not the case. That's the rule. That's not the description of a rule. That's the actual rule. So we have a representation of these rules within Dome9 called the governance specification language. And it's very, very human readable. The intent is that you do not need a developer skill set to write rules or read rules. But if you are unfamiliar with the language, we do have kind of a guided process to ensure you know the kinds of things you can measure with Dome9, and then you can build rules, in a guided fashion. I can say things like my IAM policy should have account-wide MFA turned on, And if it doesn't, I want to know about it. And as I write that rule, I can test it, and I can see that my prod domain account does not have that turned on. My users might have MFA enabled, but as an account-wide standard, that is not enabled. And that's how easy that is. So within the compliance and governance side of Dome9, there's a ton of capability. It's what we do to make that visibility and control of AWS that much more simple. I think I've probably gone over a little bit, but let's flip back to our presentation here and wrap up. Maybe we have time for a single question. That's really it. So I hope that paints a picture both of what we see in terms of industry best practices, and also why we built Dome9. The design purpose, the kinds of challenges we're trying to solve. Just gives you a taste for Dome9, but hopefully you'll come back and you'll learn more.
Great. Well, thank you, Patrick. It looks like we have one question here. The question is, how do we connect our AWS account to Dome9? Do we share credentials?
Oh, yeah, good tactical question. So how we connect accounts to Dome9 is the same really for all cloud providers. Of course, the process you follow at that respective console is a little bit different, but no, you do not share credentials. For Dome9, you can use it in one of two ways, and how you onboard is just a little bit different. You will either onboard in read-only mode, where it's kind of information only, or you'll onboard in full protection, where Dome9 will take some action on your behalf once you tell the platform what you want to see in terms of policy. And when you do, you will build some IAM policy. And if you remember, we had a slide based on sort of roles and cross-account roles. You're going to use that for Dome9. You're not going to share credentials. You're going to build a role in a policy. We'll coach you on how to do that. You'll see exactly what we can see within your AWS environment, what you can't, and then you're kind of in the driver's seat in terms of that integration going forward.
Great. All right. Well, thank you, Patrick. All right, everyone. This concludes today's webinar. Thank you for attending. If you have any further questions on the information presented today, please don't hesitate to reach out to us via the email address q&anda@dome9.com. I have a few final notes. If you enjoyed the webinar presented today and would like to experience the Dome9 Arc platform for yourself, we are offering a 14-day free trial. Please visit our website at www.dome9.com and click on the Get Started button on our home page. Just register, and a representative from Dome9 will contact you to activate your free trial. Additionally, if you liked the webinar today and would like to hear more about the multi-cloud security solutions Dome9 provides, please visit the resources page on our website and sign up for several of our upcoming webinars. If there's a topic you would like us to discuss, please contact us through our website and let us know. With that, we thank you for your time today and hope you found the content informative. This now concludes the Dome9 webinar. Enjoy the rest of your day.
Thanks, everybody.